In this video, we'll look at how to add a few types of additional information to an existing plot. These can include lines, like a line of best fit for a scatter plot, new data points, or text. We'll focus on three main functions here: AB line, points, and text. Like we have in previous videos, let's generate a data set for an example scatter plot. Two numeric variables with the names int and rand. Again, if you're going through the videos in order, you've probably already done this and don't need to do it again. But if you don't have those two objects yet, int is the set of integers from 1 to 20, and rand is created by using the rnorm function to add a small randomly generated value to each of those. Once you have those two vectors, we can use the plot function to get a basic scatter plot showing the correlation between them, like I've done here. Of course, yours will probably look a little different since the rand variable was generated by sampling randomly, but the general shape of the plot should look the same. We can see that there's a pretty strong linear relationship between these two sets of values. Let's try adding a line of best fit, since that would be a pretty common thing to do for a data set like this. The function ABLine allows you to add various types of straight lines to a plot. For example, I could add a horizontal line that intersects the y-axis at 10 simply by setting the h argument to 10. Or I could add a vertical line at the x value of 5 with v equals 5. Notice the lines are added to the existing plot. I'll just rerun the original plot function to clear them off. Now, vertical or horizontal lines can be easily defined with a single x or y value, like we just did. But a line of best fit will be defined by both a y-intercept and a slope. If we know those, we could define them with the arguments a and b. For example, setting a, the intercept, to 0, and b, the slope, to 1, gives us a line that represents a perfect one-to-one correlation between the variables. Notice I've used the LTY, or line type, argument, and I set it to 2 to make this a dashed line. Now, given we know how these data were generated, this line isn't too bad a representation. But generally, we want to estimate the line of best fit from the data. One way to do that is with the LM, or linear model function. We can pass arguments to the LM function, just like we do the plot function. So here, I'm using the same tilde notation to run the LM function on rand by int. The output from LM is in a special format, which actually has its own class, LM. We don't need to worry too much about that for now. Just know that objects of class LM include information like estimates for the y-intercept and the slope, and also that the ABLine function is able to recognize objects of class LM and pull out those bits of information that it needs, meaning you can point ABLine directly to the output of the LM function and add a line of best fit to a plot. I'll do that here, coloring it red. Now imagine we had two separate data sets and wanted to compare the best fit lines of the two. Let's go ahead and generate a second set of data. I'll call the variables int2, which just like int will be the values 1 to 20, and then rand2, which like before will add some randomly generated values to each integer in int2, but this time we'll draw from a distribution with mean 5 and standard deviation 1. Let's go back and recreate the original plot, adding the line of best fit back in with the ABLine function. Just like ABLine adds a line, the points function allows you to add new data points to the plot. So points rand2 by int2 will add this second data set to the plot. I'm setting the PCH, or point character argument, to 17 here, so the new set of points are represented by a new symbol, filled triangles. Notice some of my points are outside the original coordinates of the plot. Remember, both the ABLine and points functions add data to an existing plot. And if the data to be added are outside the bounds of the original plot, as a few of the points on here are, we don't see them. So if we want to fix that, we can go back and recreate the original plot, but adjust the xlim or ylim arguments. Here, I just need to adjust the limits of the y-axis, so it covers a range that will include all the points that will be added to the plot. 0 to 30 should be plenty. And now adding the second set of data points back in, we see them all. Just like before, I can use ABLine again and add the line of best fit that's associated with the second data set. And we see that it runs roughly parallel to the first with a higher y-intercept, as we might expect based on how we generated the data sets. Okay, so that covers adding lines and points to a plot. One final item we'll look at here is adding text to the plot region. Let's say there are a few points that are particularly interesting here, and we want to highlight those points by labeling them. One way to do that is with the text function. It allows you to add text or labels to a plot at defined coordinates. In a basic usage, we need to pass the x and y coordinates for the labels that we want to add as two vectors, one for the x coordinates and one for the y coordinates. We'll do 3 labels here, so we need 3 x's and 3 y's. And then we have to pass an argument with the labels themselves. I'll just label the 3 points A, B, and C. When I run this, notice the A label goes at the pair of coordinates made up of the first value in the x vector and the first value in the y vector. Then the B label is defined by the second value in the x vector and the second value in the y vector, and similar for the C label, which as the third label listed, it corresponds to the coordinates in the third position of the vectors. So those are some examples of adding lines, points, and text to plots in Base R. In the next video, we'll take a look at one way to arrange multiple plots on a single page.